So for our how to do a JTAG tutorial, the very first thing that we need to do is check the dashboard version on the Xbox. This particular one I've already stripped the case off of. We're going to go ahead and power it up. Super special controller over here. Super old logo is a good sign.
So once this thing boots up, what we'll have here is to go into this system. Oh, somebody's got this one set to boot to the media center. So just dismiss that with B. Scroll over to the system tab, and then we want to go into console settings, and then down to system info. Check it out, our dashboard version 6990. That's awesome, because anything below 7371 is exploitable. So 6990 puts it firmly in the area of being able to be JTAG'd. So we'll go ahead and turn off our Xbox and get everything prepped so that we... Okay, so the reason I'm showing you this image real quick is just to touch on the difference between Xenon and non-Xenon JTAGing. Basically, we just want to establish what motherboard revision we have. So if we look at the power socket on the console that we're doing, we can see that the bar across the very top is solid, and it's got the 6 little dots, or connections, but there's no little center dimple bit, and it does have HDMI. So if we follow along with this image, we can tell that that means we have a Falcon. That means, as far as JTAG goes, is that there's JTAG for Xenon wiring, and then there's non-Xenon, which is everything else. So because we know we have a Falcon, we will use non-Xenon JTAG wiring, which is anything but a Xenon, and that will allow us to get our JTAG, everything up and running. So just make sure that you're aware that this tutorial is only for non-Xenon motherboards, and you need to identify what motherboard you have first.
Alright, so what I've done now is checked the dashboard version. I've gone ahead and disassembled the 360, taken it out of its case. I actually went ahead and blew it off with some air too, so it's nice and clean now. The first thing that we're going to do to actually start the JTAG process is we need to dump the NAND. The way that we'll do that is by soldering the NAND connections to the J1D2 and J2B1 sockets. So there's the J1B2, J1D2, excuse me. And then here is the other one. I will throw up an image of the pinout diagram. I use a NandX, which is a Team Executor product, in order to do this. There are LPT cables and stuff you can make, but I'm telling you, if you want ease of use and support from everybody on the internet, the Team Executor NandX or the JR programmer, which is just their upgraded version, and the pinouts that they use are ubiquitous across the internet. So next, I'm going to solder those on, and we'll continue from there. Alright, preparing of the NAND connections in order to actually do the soldering, you're going to want a fiberglass scratch pin. These can be had pretty cheap online, $7-8 at Radio Shack even. What this does is it removes the top layer or coating on the board that will prevent you from being able to make a good connection. So what I'm just going to do is pretty gently rub this back and forth across the connectors here where we're going to be doing the soldering for the NAND header. And again, this is something that is necessary. It is not an optional step. Don't go to try to solder without doing this sort of thing. It's all part of the proper soldering process. So here's the other, let's see, NAND header. And the ones that we're going to use here are kind of a couple over. That's why I'm not doing the whole set of pins. Make sure you're using flux, you're doing your solder correctly. There's tons of video out here on YouTube about how to solder. Watch them, pay attention, otherwise you will burn the shit out of your Xbox and you will not end up with a cool, awesome JTAG. You will end up with a useless hunk of crap that you burned. Alright, we'll do the soldering next. Alright, managed to get a decent camera angle on this, so I think I will try to show you guys the soldering. I am going to apply liberally some flux here to the area that we're going to be soldering to. That's actually like SMD rework flux. It's not the most ideal for this circumstance, but it's what I have on hand because my son squirted out the rest of my flux on the floor. So this is soldering iron, and I'm using a slightly wedged shape soldering iron tip. It's not completely fine, and it allows me to get down in there and actually apply the soldering a little more. I'll give you a diagram in the comments and on screen here of where exactly these are going. Tin my iron a little bit. Should have done that before I started. And how they're going to be wired up to the connector. So the point of my process right now is just to get a little bit of solder flowed onto each one of these spots. So that later, when I come back with the connectors that I'm going to make, everything will just stick nice and easy to it. So now that I've got that done, and I'm stopping with those because those are the only ones that we're going to solder to, I'm just going to clean it up with a cotton pad. You can get these in the dollar store, like Family Dollar or whatever. A whole package of a ton of them for $1. And they work really good for this. Alright, so you can see now I've got my spots with a bit of solder on each of them ready to be soldered to. One of the nice things about the NandX cable is if you look at the head of it here, it's actually done in order of how you're going to do it. And you can kind of learn those ways. So black is my first 1, 2, 3, 4, 5, all the way through the connectors that you're going to do. So the very first connector that we're going to plug in or going to hook up is to this one in the corner here. It's the black one, and that's pin position number 1. So what I'm going to do is just touch the soldering iron to that. And now we've got a nice little, see, that's why we pre-tin it. So that's all connected nicely. So then connection number 2 is brown wire. And again, guys, use your reference image. Don't be using my video for this. That would be kind of silly. I'm gonna pull this whole bit back this way while I do that. So there's number 2. 3 is the red in this third position right here. And there's 3. 4 is the orange. Next one over here like so. And the last one, yellow, in the 5th position, is actually ground. So if it's like crazy and you really don't think you can get the last one in there or whatever, if you can ground it off to the AV port or something else, it'll still work because it's just ground. So there's that one connected. So there's all of those in that section connected. I'm going to move the camera to get another look at this pin header, which is where we got 2 more connections to make, and we'll show wiring those up. Alright, so I've already used my fiberglass scratch pin and desurfaced this area a little bit. These two pins are 1, 2, and then it's the third ones over, top and bottom there. So I'm just going to apply a little flux like we did before. And then I'm going to tin each of these just like we did the other ones. See, that's cold solder a little bit. I've never known it to affect for my purposes, but it bugs some people when the solder doesn't turn out shiny. I don't know. As long as you don't burn the board, don't go overboard trying to get it shiny. Wipe it up here. That probably has something to do with the not super specifically designed for it flux that I'm using. So there's my two spots that I'm going to be soldering to. These are the last two wires off of the thing, the blue and the green. I like to do number 6, the green one first, so I can reach it from the top side. So that's what we'll do here. So again, I'll just touch a little bit. And there's that connected. And then the blue one here, we'll just do the same thing. Just touch the soldering iron to it just to get it moving. And there's 7. So now all of our connections are made to our NAND pin header so that we can read the NAND. I'll set up for it and walk you guys through dumping the NAND multiple times, comparing it, verifying that it's exploitable and all that here next. Alright, so now I've got my NandX plugged in via USB to my computer. I've got it plugged in via the only connector that fits into the pin headers that we soldered. And I've got the power connected to the motherboard. Power only. I have not even connected the RF board, not turning it on. We just want the power connected and the power plugged in because that's going to provide power to the chip so that we can read it. Then we're going to come over to JRunner and we're actually going to read the NAND, and I'll do that from a screenshot.
So what you can see here is that I have the number of reads indicated as 2 in the upper left here. Number of reads, 2 NANDs. Then we're going to hit the read NAND button. First it's going to get our config, and then it's going to start reading the NAND. So there's our config, which would tell us what kind of motherboard we have. It also immediately tells us our CB, which we know is exploitable now. And that's progress bar is what is telling us that we are in fact progressing through reading the NAND. So I'm probably going to put a little high speed here to take us through that. Okay, I'm slowing it down here for just a second to show you that if you click that Show Output folder here, you're going to get the folder where it's storing the NAND dump. And it's in progress right now, so the file's not completed. But once it completes, it would be a good idea to take both of the NAND files and make a copy of them and put them in a location that is not accessible to JRunner, just to make absolutely sure you've got a good backup copy of your NANDs somewhere that it can't get to. So now that we're about to finish our first dump, what you're going to see here is that it will start immediately a second, and that's because we've told it to do 2 dumps. So there's the first NAND dump completed, and immediately it started reading for the next, and you can see it's immediately started reading because we told it to do number 2, and it's going to progress through this. So this is sped up. It's just doing the second dump. I wanted to make sure that was notated. I'm clicking around a little bit and looking at the different details that you can see now that we have a NAND dump. So now that it's slowing down, it's nearing the completion of the second dump. What we want to see here is after the second dump completes, it's going to do comparing the NANDs, and we want to see it say right here, critically important, NANDs are the same. If your NANDs are not the same, do not proceed. Double check your soldering and start over and do your dumps again. Do not proceed unless you have 2 good matching dumps. So from here, what I'm going to show you real quick is how to just copy what's in the working folder over to another folder that JRunner doesn't have access, just to again make sure that we've got a good copy of the NAND somewhere that we can't lose it.
Okay, coming back to the real world here too, we're about to finish up our second NAND read. And this is the big critical part, and we'll show you on the computer as well. But we want to compare, NANDs are the same, and we want that. If we don't have two identical NAND dumps, we stop, we review what we've done because we're doing something wrong. If you do not have NANDs are the same, two identical NAND dumps, do not continue. So what I'm going to do now here on this side, I haven't touched anything. All I'm going to do is unplug, and then I'm going to disconnect here.
Now that we have two good dumps of our NAND, we need to create the Xell image that we're going to flash. We know we have a Falcon, so we'll select the Create Xell and select Falcon, and it'll create a falcon.bin file. This will actually be in the output folder. If you hit the show output folder or look in the output folder, you can see the falcon.bin file there. This is what's going to get written. Now in order to write the image, we need to plug our NandX back in and rehook up power to the Xbox so the NAND's powered. Not turn it on, there's no RF board, just power and NandX plug. You can come back into JRunner and click write, and it'll write really quickly because it's only writing the first 50 blocks. So this is not sped up at all, this is just how quick that goes. So now we've written Xell to the NAND, we can disconnect power and disconnect our NandX.
Okay, so what I've done here without recording, unfortunately by accident, is I have taken and pre-tinned these spots. So just like we did here, I used the fiberglass scratch pin, and then I tinned this spot, and then these three. This will jump to here, and then these two will be the connections that we'll use the ones on the diodes on. All that's outlined in the image. Okay, so here is our little jumper wire that I'm going to use to connect from here to there. You can get it a lot shorter than that if you want. I'm just using this because it's a little spare bit that I had laying around. The length from what I have used and seen and all that sort of stuff has really no impact. So there's that end. I'm going to use a pair of tweezers to get this end in. I'm just going to loop that around. Come back to right there. Maybe I'll get this to lay down a little more. Doesn't really matter, it's all way lower than anything, nothing's going to be touching it. So there, I've bridged this point with this point using the little jumper wire. Again, you can use a short piece if you want, I just used what I had laying around. No big deal. Alright, so we know our goal, next goal from looking at the image here is to attach this point, which you can't see with my big finger in the way, this point here to this little bitty point here. We're doing that with a resistor. A diode, and this little diode, see how it's got the little black bit on the bottom? That needs to face this end. And if you look, if we put that down here, it's just the right length to actually make it. But we don't want all that exposed wire making contact with everything else and messing it up. So what I'm going to use is a little bit of heat shielding. Now the alternative to this would be you could solder a little wire on one end and then a little wire on the other end and connect it and wrap that whole bit in heat shielding. What I'm going to do is put some heat shielding over the whole thing, except for leaving the bottoms exposed, and then solder it directly on there. So to prepare for that, what I'm going to do here first is get this spot ready by just running the fiberglass scratch pen over it a little bit. I'm going to dab a little bit of flux on there. And then I'm going to go ahead and tin that spot with some solder. Don't worry if you have a big glob there, or you don't have a big glob there. The point is that it'll stick to the wire once you get it there. So now I'm just going to clean that off. So what I'm going to do is I'm going to stick this over the end so that just the end is showing. Then I'm going to cut it off on this end just so it's hanging out. And then so what I've done is I've trimmed the heat shrink tubing to where just a little bit on either side is out. I'm going to make sure that you know the orientation of where the little black part is. So what I'm going to do is hold the end of it with this so I don't burn myself. Then I'm just going to use a lighter to shrink it. Alright, so now that we got our resistor prepped, I'm going to go ahead and install it. The way that I'm going to start doing that is I'm going to get some solder on my iron. And I'm going to just dab it over the end here. And the first thing that I'm going to do is install this end on the little spot there. Alright, so now that that's in place, what I'm going to do is get a little more, clean off the old solder, get a little more solder on the iron. I'm going to use these tweezers to hold this down. And there we go. We are jumped from that position to here like we're supposed to be. Because it's so flat, nobody will really mess with it. We don't have to worry about it getting any pressure on it or anything like that. So now our next position is going to be to go from this. You know, there's quite a few people that talk about installing it to the ring of light board. There's an alternative spot where this actually connects to right on the underside of the motherboard. And I like to use that strictly because then if you ever need to disassemble the console again, you don't have to worry about that ring of light board being attached. So this is actually the underside of the board. And what we're going to do for this part is wire that other diode that we have to the point that I was talking about, which is on the underside of the ring of light board where it connects to. So if you find the ring of light connector, it's this set of pins right there next to it. So let me get the camera stationary here. So again, we're going to pay attention to the little black part. We're actually going to be connecting that to the second one over from the end here. So it's going to connect to this spot right there. So what I like to do is just take the brush, and this just cleans a little bit of the crud off because these are actually kind of pointy and have more solder on them. And then I'm going to put a tiny bit of solder paste and I'm going to tin up this spot. So this is again the second one over. Get a nice bead of shiny solder on there. Clean this up. Don't want to put so much that it touches the other spots. I might have actually put a little too much solder on there. Soak a little bit up with my iron. What I'm going to do actually is just run the connector this direction so that it can go towards where the other wire is that is going to hook up to. But I don't want all this loose and just hanging out. So what I'm going to do is run this through a piece of heat shrink tubing again. So again, little black part facing the connection. I'm going to just slide this over that. So again, just holding it with a pair of pliers so I don't burn myself. I'm just going to use a lighter to shrink this. A little bit of heat shrink tubing. Boom. So that's all we're going to do. I'm not going to try to go crazy and overheat it like I did last. Do now is position this so that that will connect like it needs to, and solder that bugger in place. There we go, reasonably happy with that. So we're soldered down, missing the hole, we run lengthwise here. So now it'll be real easy to just add another length of wire to the end of that and run it up to the connection that we need. Okay, so all I'm going to do now is just real simple. Put a little bit of solder on the end of that, connect my length of extension wire, we'll put a little piece of electrical tape around that and hold it down with it so it won't be an issue, and then we'll go topside. Alright, so just cut a real small piece of electrical tape, pin that down there, and then I like to just use another little small bit just to hold it in place. So now we can flip the board over and this is our little bit that we extended from below, and we're going to solder it in place. What I'm going to do here with the routing is just kind of tuck it up underneath there a little bit, and then I'm going to trim it so that it's a little bit better of a length. So there's that. Get a little bit of exposed wire on the end. Trim it down so it's reasonable. Take our soldering iron and our tip with a little solder on it. Pre-soak the end of the wire a little bit and get this one right in place as well. There we go. So now you can see we've got that connected and just running along the bottom as well. We've done all the wiring that we're required to do. Here's the real test as we boot it, and we should get Xell. Okay, so all I've done now is put it back in the case, put the fan back in, put the shroud on, put the ring of light on, and everything's already wired up. It's connected. I did plug in a network connector, and you'll see why here in just a moment, because we can actually grab the CPU key over the network rather than having to type it out. So what we're going to do is go ahead and press the button to boot this up, and if everything is done correctly, we should get Xell on screen on the monitor. So we'll hit the button, and I switched out the ring of light board for a blue one that I had. Look at that! Xell! So what this is going to do is give us our CPU key, which is the crux of the whole deal. I'm not going to zoom in anymore so you guys can read mine. But if you look at these two little bits of data, you're going to have your CPU. You know what? Who cares? This portion has your CPU key in it, and then they go ahead and just spell it out for you right there. CPU key, DVD key, and it's all really easy. Now this is the part where it's neat. Because I'm plugged in the network, 192.168.11.59. So what I can do is come here, I'll switch my input to my computer, and I'll come here. So I've already got my local network, 11.24. So I'll just type in 59, I think, right? And I'm going to hit get CPU key, and boom, added to database. CPU key populates up there, and now we have everything we need. The create image shows up, and we can actually create a full-blown image to boot with. So we will have a fully functional JTAG here real quickly.
So now that we're on the computer, we've already created our Xell, we've written it to it, we've booted Xell, we got our CPU key via the IP option, so we didn't have to type in. Typing in is an option though. We can use these tabs here to see all the information that it's unlocked. We got our DVD key, we know what our OSIG was for our original drive type, so all we need to do at this point is make sure we have a JTAG image selected, and then we can actually modify any of the dash launch any options here. I'm not going to go into that stuff. There's other tutorials out there for that. But we're going to verify our CPU key and create an image. We've got to select Falcon again, so that's pretty default. We know we have a Falcon board at this time. If we look in our output folder after this completes, we will now have a UPD flash in our output folder. It does change the folder name to the serial number of the Xbox and store it. So you may have to actually change where you're looking to that serial numbered folder, but there's our updflash.bin, and we'll grab a copy of that and put it into our side folder where we've been saving other copies to, just for the in case sort of thing. But that's the file that is now going to get written back that contains our hacked dashboard basically. So we're going to go ahead and plug back in our NandX, plug back in power to the Xbox, and we will begin writing the hacked image back to the Xbox. So this part will be sped up again here, but this is just the writing of the image that we've created back. Now this image contains both Xell and our full-blown hacked dashboard. So we've completed, or are about to complete. We can see that it's done here now. We can disconnect the power to our Xbox, disconnect the NandX, and we're ready to try our first boot.
Alright, we just got the done message in the log that we're done writing to it. So what I'm going to do is just disconnect the power, and then I'm going to unplug my NAND reader writer. And they say, I've read a lot of places, that you're supposed to let it sit for 30 seconds or a minute. I've never really timed it or counted or anything. But the idea is to let the NAND lock in. I've never really heard a great explanation for it. I've never done it without unplugging it in the middle, gone straight to trying to boot. But unplugging it for 5 or 10 seconds seems to be more than enough. So our very last step here now, as I was reconnecting the video and the power, not the NAND reader, because we just wrote the NAND that we want to try to boot, is we're going to try to boot, and we should get a full-blown 16202 dashboard that we selected. So there's our blue LEDs. Here we go. Look at that. We have got a fully functional JTAG'd Falcon Xbox 360, which means it also has HDMI. It's still booting straight to the media center. That's a setting we can turn off. But yeah, that's definitely it. I'll go through probably another video another time how to set these up, JTAGs or reset glitches, because it's the same process, but that'll be a separate video. But there you go. You've successfully glitched it. The last thing that we'll do is I'll remove the NAND reader writer cables, because we can actually read and write the NAND through the Xell going forward. I just turned the power off just to show you that The way the full-blown thing works is if you press the eject button. So if I reach in this little hole and boot it with the eject button, what we will get on screen immediately is Xell. So you got a selectable boot. You can boot eject button boots Xell, regular power button, or a controller will boot the dashboard. And Xell is nice because you can flash your NAND through Xell. If you load a updflash.bin onto a thumb drive and put it in during this process, it will actually flash that to the NAND.